Hello everyone. Today we are going to analyze this fixed beam. In this beam there are 2 point loads. Both of them are having the same magnitude 12 kilonewton. This load is acting at the distance of 2 meter from the point A and this load is acting at the distance of 4 meter from the point A. In this beam, we have symmetrical loading. The total length of the beam is 6 meter. Now we are going to find the fixed end moments. For that, we can use the formulas. If in the fixed beam there is an eccentric point load, the formulas to find the fixed end moments are WAB square upon L square and WA square B upon L square. Using these formulas, let us find the fixed end moments. First, let us take this load. For that load, we can use these two formulas. Here, W is 12, A is 2, B is 4, and L is 6. Now, let us take this load. For this load, let us use these two formulas. Here, W is 12, A is 4, B is 2, and L is 6. After adding these two, we will get MA, and after adding these two, we will get MB. We know that in this beam we have symmetrical loading. That is why for MA and MB we have got the same value, but MA will be acting in the anti-clockwise direction and MB will be acting in the clockwise direction. We have found the fixed end moments. Now let us find the vertical reactions RA and RB. In this beam there is symmetrical loading, so we can easily find RA and RB. To find RA and RB, we have to divide the total load by 2. Here there are two loads, 12 and 12. We have to add both of them and then divide by 2. When we do that, we are getting RA and RB, which are 12 kilonewton. Now we are going to draw the shear force diagram. I am going to find the shear force values from the point A and towards the point B. In this case, I am moving towards right hand side. Upwards will be positive and downwards will be negative. Using that rule, we can find the shear force values. Here you can see the shear force diagram. Now we are going to draw the bending moment diagram. For that, first we have to assume the fixed beam as a simply supported beam. You can see that I have assumed the fixed beam as a simply supported beam. We know that in this beam we have symmetrical loading, so we can easily find RA and RB, which we have done already. To find the bending moment in the point C, we have to multiply RA with 2. 12 into 2, we get 24. To find the bending moment in the point D, we have to multiply RB with the distance 2. 12 into 2, here also we will get 24. Then we can connect this line and connect to the bottom line. This diagram is called the free movement diagram. Then using the fixed end movements, we can draw the end movement diagram. For MA, we have got 16. For MB also, we have got 16. Since both of them are same, we have a rectangle shaped diagram. Then we can combine both of the diagrams so that we will get the bending moment diagram. If we wanted to find the maximum positive bending moment, we have to find this height. 24 minus 16, we will get 8. Alternatively, we can draw the bending moment diagram by finding the bending moments separately for all the points. To find the bending moment values in the points A and C, we can use right hand side rule. Clockwise will be positive and anti-clockwise will be negative. Let us find the bending moment in the point A. In the point A, we have MA, which is acting in the anti-clockwise direction, so that it will be negative. Let us find the bending moment in the point C. MA is acting in the anti-clockwise direction, so that it will be negative, or A is acting in the clockwise direction, so that it will be positive, and the distance is 2. Finally, for the bending moment at C, we are getting 8. To find the bending moments in the points B and D, we can use left-hand side rule. Clockwise will be negative and anti-clockwise will be positive. Let us find the bending moment in the point B. In the point B, we have MB, which is acting in the clockwise direction, so that it will be negative, or B is acting in the anti-clockwise direction, so that it will be positive, and the distance is 2. Finally, for the bending moment at D, we are getting 8. Using the values, we can make the bending moment diagram. You can follow any one of the method, whichever is easy for you. In these 2 points, the bending moment becomes 0. We can find the location of these 2 points. This diagram is symmetrical, so both of these 2 distances will have the same value. I am going to take this point and I am going to make a section in this point. You can see that I have made a section in this point. We know that in this point the bending moment is 0. Using the right hand side rule, we can find x, which is 1.33 meter. Let us apply that. Now we are going to end this session. Thank you for watching this video.